Hello everyone, my name is Aryan Thakur and I am your TA for the C69 course. In this short video, I would like to sort of describe the system calls mmap and munmap. Let's get started with the mmap system call. As you see, the mmap system call should return a map ID, and it sort of takes in two arguments. The first one being the file descriptor argument, and the second one being something known as a void pointer, and that is the address, the user space virtual address. Now, what exactly does mmap do? So, mmap is a system call which would map an entire file from the file system into the process's user space. There are a couple of examples in the repository which you could see, and I believe they are they're in the examples folder with the name mcat.c. Um, so coming back to what I was saying, we map the entire file into the user space, into contiguous pages in the user space. Int fd is the sort of reference we have to the file we want to map. The file descriptor, as we know, has a sort of open file associated with it. And that is the file we want to map from start to finish from the where the start address is this void adder. It is important to know that these pages should be contiguous. We can start this mmap by performing a few error checks before we can really get into this the main meat of this function. Um, a couple of reasons to fail it would be if the um, file length is sort of zero. We can we can't definitely have a mapping if the length is zero itself. Um, if any of the files if any of the files, I mean, you have contiguous pages which you want to map. If any of these sort of map pages already would have a mapping, sort of something like a previous M mapping or something, if it's something like a stack page, you need to immediately end this function. Of course, the address zero is impossible to map to, and the file descriptors zero and one, which are really referring to something like the user console, of course, are not mappable. So that would go under the sort of initial error checking which you could have. Of course, the checking if it's already mapped would be something which you would do later um, to simplify things. Once you perform your initial error checking, you can get into the real lazy loading of these mapped pages. And it is very essential that you do conduct lazy loading and you do not load the entire file from the file system into the user space at once. So here we would do the lazy loading of the file. Um, Here would be, I think, a great time to keep the check of if the page is already mapped, just to simplify things. So the lazy loading of the file is the main part of the function. You should, of course, I think I didn't mention this before, but you should, one of the main error checking is if the address isn't page aligned, you should not go ahead with this function. And you need to map contiguous pages. Of course, the page size is 4096 bytes. So every 4096 contiguous pages, 4096 contiguous bytes, you can conduct this M mapping. It is very likely that the entire length of the file won't be exactly page aligned. So in the last page where you may have something like an incomplete page, you need to zero the ending sort of bits, ending bytes of this page. Um, I think it's worth noting that you must always use file reopen, the function file reopen when you create this mapping to this page. The FD refers to its own file pointer, but this mapping should exist whether that file pointer is closed or not. For that reason, to obtain sort of an independent reference to the file yourself, you can use the file reopen function. And I do suggest you read that in the documentation and sort of understand what the function exactly does. Um, yeah, one other suggestion I would like to give you is that you can use the PAL0 flag when you are allocating these pages. In the case of a page fault, of course, since it's lazy loading at the end of the day, to automatically, in a way, zero the last bits of the last page. Um, I don't think I should be explaining lazy loading, but lazy loading sort of means that you only load this page when it's required. Basically, when you hit this page and you receive a page fault, that's the time you load this page. It's not preloaded in a way. So that's what lazy loading is, and that's what's required for the Nmap. A good way to do this is in your supplementary data structures. You can map these contiguous page. I mean, you can mark these contiguous pages that they are sort of Nmap pages and provide all the necessary details you would need in a case of a page fault when you need to load it from the file system. I would say that is sort of the main structure of Mmap. For Unmap, we can see that it's a void return data type, and it just takes in a map ID T mapping. Um, I think I forgot to mention that this mmap should ultimately return something known as a map ID. It's similar to the file descriptor which you already implemented in your second project, and it's sort of something you should have a data structure which can, where you know which mapped sort of file relates to what map ID, which is useful in the case you have the unmap function. Now note that unmapping a mapped file in the user space does not need to be explicitly called like we have here void munmap, which is a system call which explicitly mentions that you should start unmapping the files. There are implicit calls to munmap too in the case of when a process exits. For any reason, if it exits, you need to unmap the files. And what exactly does unmapping entail? Um, Unmapping is the process of writing the dirty pages of the mapping specifically back to the file system. You don't need to write every single page back, just the dirty pages. And the dirty pages are a way of saying the pages that have been written to. Each of these pages have something known as a dirty byte, which you can check to know if the page is written to or not. Um, so that is basically the unmapping system call. You just need to write back the pages into the file system. Of course, you must know that mapped pages are never in the swap disk. They're only written back to the file system. And a couple of things to know in the unmap system call is that it is possible that two processes map the same file. And in Unix, of course, that's a very sophisticated and advanced operating system. In that operating system, what they do is maintain the same physical page for how many ever processes map the same file. But that's not something which you need to do for this project. What you should really think about is just that the last write wins. Something like how we have a GitHub commit. Okay, not exactly like that, but um, yeah, the last write win basically means that if process A writes to the same file and then process B writes to the same file, we just need to take what process B wrote to the file. It's as simple as that. So munmap is just write back dirty pages. Of course, once you write back the dirty pages, you clear them from the page directory and delete your supplemental data structures. And yeah, I think that's it for the two system calls. They are pretty simple if you break it down into sort of the small components which make up the system calls. And I don't think you would need to spend too much time on developing these two system calls. And yeah, I hope you all have enjoyed this video and have learned something. And I wish you the best for Project 3. Thank you.